Alright team, let's look at a Leetcode problem called 2sum. It's an easy problem. So here is the problem statement. You're given an array of integers called nums and an integer target. Your function should return the indices of two numbers such that they add up to the target. Right? They say that you may assume that each input would have exactly one solution and you cannot use the same element twice. Right? So let's look at an example here. So you have this input array. It contains 2, 7, 11, 15, and your target is 9. Right? You want to find two numbers in this array that add up to the target. Right? So in this case, the answer is 0. Sorry, in this case, the answer is 2 and 7. Right? 2 plus 7 is 9. But you want to return the indices and not the numbers themselves. Right? So 2 is at position 0, so we return a 0 here, and 7 is at position 1, so we return a 1 here. Right? In the second example, you can see the input numbers are 3, 2, 4, target is 6. We have two numbers that add up to 6. So we return their indices, right? 2 is at position 1 and 4 is at position 2. And they say that there will always be a valid answer. So a valid answer will exist. Your input array can be of there will be minimum two elements in the array, and at max there will be 10 raised to 4. These are the values, the possible values in your input array, and the target will be in this range, right? Let's look at let's go to the whiteboard next.
Let's look at an example here, right? Let's say we have an input array that has three elements in it, 3, 2, and 4. And let's say our target is 6, right? Now, our goal is to find two numbers, right, in this input array that add up to 6, right? The easiest possible way I can think of is why not have two pointers, one starting at the first position and one starting at the next, right? The pointers cannot start at the same position because we cannot use the same element twice, right? We want to use different elements. So if we go with this two pointer approach, our equation becomes really simple, right? We just need to check if nums I plus, let's call this array nums, right? Nums I plus nums j equals to the target. If it's equal to the target, that's it. You found your answers, right? You can simply return I and j, and the job is done. So let's walk through this, right? I starts at position 0, j starts at position 1, and let's go through this. So our first calculation will be 3 plus 2. Is it equal to 6? The answer is no, right? We simply move on the j pointer to the next number. We check again. Is 3 plus 4 equal to 6? No, right? That's it. We have checked 3 with every other number in our input, right? The next thing we do is we gradually then start from looking from the next number, which is 2. So our I starts from 2 and our j is starts from 4, right? We can ask the same question again. Is 2 plus 4 equals to 6? The answer is yes. That's it. You found your answer, right? 1 and 2 is your answer. So that's one possible way you can solve this problem. Again, here if you think about it, for every number, you have to look at every other number in the array, right? So basically, for every number n, you end up looking at every other number which which is equal to n minus 1, right? And this ends up to be n square. So the time complexity of this function is going to be big O n square, right? And we don't use up space, so space will be big O 1. So the next logical question to ask is, okay, can we do better than big O n square, right? Is there a linear solution out there waiting for us? And the answer is yes, right? So in the brute force solution, we said, okay, if nums I plus nums j equals to target, we found our answer, right? So let's pull out this equation, right? So we said nums I plus nums j. If this is equal to target, we found our answer, right? Now, Let's rearrange this equation a little bit, right? What if we say target minus nums I equals to nums j, right? This is equivalent. Both of these equations are equivalent, right? We just rearranged. We brought target to the LHS and we took nums j the RHS, right? So our new equation becomes target minus nums I equals to nums j, right? And let's think about this. Let's say we have our example here 3, 2, 4, and let's say our target is 6, right? So according to our equation, target minus nums I equals to nums j, right? And these numbers have indexes 0, 1, 2. Okay. So for first number, right, let's say we start I from here, right? For first number, the answer is going to be what? So 6 minus nums I, which is 3, and nums j becomes 3, right? Once we get this, once we get the value of nums j, the next question then becomes, okay, can we easily find nums j in our input array, right? One way is to go through each number one by one, and then the time complexity becomes big O n square again, right? Because for each number, if you're going to go over each number again, it's going to be big O n square time complexity. Is there a better way? What if we had an operation that would give us nums j in constant time, right? Is there a data structure out there that would store the values or store our input values and give us an answer in constant time, right? That would help us immensely to reduce the time complexity, right? And yes, there is a data structure out there. It's called hash table or map, right? So imagine this. Imagine before we do anything, we build a map. We build a map where the key is an int and the value is also an int, right? The key is basically the numbers in your input array and the value is their indices, right? So we already pre-built this map. So let's say 3 is at index 1, sorry, 3 is at index 0, 2 is at index 1, and 4 is at index 2, right? We already have this map pre-built, right? Then what we can do is we can go over the numbers one by one in our input array and use our new equation, right? If t minus nums I, if the value of this equation, if it exists in the map, that's it. You found the answer, right? So that way you get to reduce the time complexity to big O n. Right? Looking up in a map is going to be a big O1 operation, and in the worst case it can be big O n, but let's assume it's going to be big O1 each time, right? And that way you get to reduce your time complexity.
All right, team, enough talking. Let's write some code. Okay, so let's code up the optimal solution. Right, we said we are going to make use of an unordered or a map, right? So let's use unordered map because they are slightly better in C++. And we said our key is going to be an int and our value is also going to be an int, right? So the key will be uh, the value that's in the numbers that are in the nums input array, and the value is going to be the index of those nums, right? And let's call this map cache. So we are going to go over each number in our input array one at a time. So int I equals 0, I less than nums dot size plus 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 I, right? And if you remember, our equation was target minus nums I equals to nums j, right? So what we can do is we can check if target minus nums I, if it exists in the map, that's it. We found our solution, right? So we can do cache dot, we can use the count function that checks if the key exists in the map or not, and we can check for this value, right? If target minus nums_i exists in the map, then you found your answer. So you can straight away return I, which will be one of the values that adds up to the target, and your second index will be the value at this key, right? The key at target minus nums_i, right? That's it. You found the answer. And if if target minus nums_i doesn't exist in the map, we still need to store it, right? We still need to keep a track of the values and their indices, right? So we can simply store nums_i in the map, right? So nums_i equals I. And just to return something here, we can return an empty array, because otherwise it's not going to compile. It's going to say that the function is not returning anything, right? So let's run this. There you go, runtime 0ms, and if we submit this solution, there you go, beats 77% 3ms. Guys, hopefully you enjoyed this video, and as always, if you have any questions or feedback for me, please post them in the comment section. I'll see you next time. Thank you very much.